everybody, and welcome to another ASMR video here on the channel. Now, as promised in my previous video, which the promise was made at the end, so some of you may have missed it if you were asleep. Today is the start of a new sort of mini-series we're going to be doing for the foreseeable future. As I mentioned, my fact videos about space have always been really popular. You guys are always asking for more space content. I think my first 1 hour facts video about space is my best performing video ever by a long way. So I figured, why not give the people what they want, and essentially I'm going to be starting a new series. Don't know what it's called yet. Something about let's learn about space, whatever. And each installment will look at a different element or aspect of outer space and break down the sort of facts and history, learnings, what we know, all of that good space stuff. And in tonight's video, as you can tell by the title, we are kicking things off with the Milky Way. And there are loads of different elements to outer space, so be sure to leave some topics or specific planets you might want to see detailed videos on in the comments down below. But without further ado, let's get into the Milky Way. So, the Milky Way is the galaxy that includes the solar system, with the name describing the galaxy's appearance from Earth, a hazy band of light seen in the night sky, formed from stars that cannot be individually distinguished by the naked eye. The Milky Way is a barred spiral galaxy with a D25 isophotal diameter estimated at being 87,400 and 3,600 light years, but only about 1,000 light years thick at the spiral arms. Recent simulations suggest that a dark matter area, also containing some visible stars, may extend up to a diameter of almost 2 million light years. The Milky Way has several satellite galaxies and is part of the local group of galaxies which form part of the Virgo supercluster, which is itself a component of the Laniakea supercluster. It is estimated to contain 100 to 400 billion stars and at least that number of planets. The solar system is located at a radius of about 27,000 light years from the Galactic center on the inner edge of the Orion arm, one of the spiral-shaped concentrations of gas and dust. The stars in the innermost 10,000 light years form a bulge, and one or more bars that radiate from the bulge. The galactic center is an intense radio source known as Sagittarius A star, a supermassive black hole of 4.100 million solar masses. The oldest stars in the Milky Way are nearly as old as the universe itself, and thus probably formed shortly after the dark ages of the Big Bang. Galileo Galilei first resolved the band of light into individual stars with his telescope in 1610. Until the early 1920s, most astronomers thought the Milky Way contained all the stars in the universe. Following the 1920 Great Debate between astronomers Harlow Shapley and Herbert Curtis, observations by Edwin slain by Enlil of Nippur, but is now thought to be purely an invention of Babylonian propagandists, with the intention to show Marduk as superior to the Sumerian deities. In Greek mythology, Zeus places his son born by a mortal woman, the infant Heracles, on Hera's breast while she is asleep, so the baby will drink her divine milk and become immortal. Hera wakes up while breastfeeding and then realizes she is nursing an unknown baby. She pushes the baby away, some of her milk spills, and it produces the band of light known as the Milky Way. In another Greek story, the abandoned Heracles is given by Athena to Hera for feeding, but Heracles' forcefulness causes Hera to rip him from her breast in pain. Lys Dawn, literally meaning the court of dawn, is the traditional Welsh name for the constellation Cassiopeia. At least 3 of Dawn's children also have astronomical associations. Caer Gwydion is the traditional Welsh name for the Milky Way, and Caer Arianrhod being the constellation of Corona Borealis. In Western culture, the name Milky Way is derived from its appearance as a dim, unresolved, milky, glowing band arching across the night sky. The term is a translation of the classical Latin Via Lactea, in turn derived from the Hellenistic Greek, short for, I'm not going to say that, Galaxius, Kyklos, there you go, meaning a milky circle. The ancient Greek Galaxius and Iak is also the root of galaxy, the name of our and later all such collection of stars. The Milky Way, or milk circle, was just one of 11 circles the Greeks identified in the sky, others being the zodiac, the meridian, the horizon, the equator, the tropics of Cancer and Capricorn, the Arctic Circle, and 2 colour circles passing through both poles. Okay, now diving into the astronomical history. So ancient naked eye observations. In Meteorologica, Aristotle states that the Greek philosophers Anaxagoras and Democritus proposed that the Milky Way is the glow of stars, not directly visible due to Earth's shadow, while other stars receive their light from the sun but have their glow obscured by solar rays. Aristotle himself believed that the Milky Way was part of the Earth's upper atmosphere, along with the stars, and that it was a byproduct of stars burning that did not dissipate because of its outermost location in the atmosphere, composing its great circle. He said that the milky appearance of the Milky Way galaxy is due to the refraction of the Earth's atmosphere. The Neoplatonist philosopher Olympiodorus the Younger criticized this view, arguing that if the Milky Way were sublunary, it should appear different at different times and places on Earth, and that it should have parallax, which it does not. In his view, the Milky Way is celestial. This idea would be influential later in the Muslim world. The Persian astronomer al-Biruni proposed that the Milky Way is a collection of countless fragments of the nature of nebulous stars. The Andalusian astronomer Avambes proposed that the Milky Way was made up of many stars, but appeared to be a continuous continuous image in the Earth's atmosphere, citing his observation of a conjunction of Jupiter and Mars in 1106 or 07 as evidence. The Persian astronomer Nasir al-Din al-Dusi, in his Tadkira, wrote, "The Milky Way, i.e. the galaxy, is made up of a very large number of small, tightly clustered stars, which on account of their concentration and smallness, seem to be cloudy patches. Because of this, it was likened to milk in colour." Ibn Qayyim al-Jawziyya proposed that the Milky Way is a myriad of tiny stars packed together in the sphere of the fixed stars. So moving on to telescopic observations. Proof of the Milky Way consisting of many stars came in 1610, when Galileo Galilei used a telescope to study the Milky Way and discovered that it is composed of a huge number of faint stars. Galileo also concluded that the appearance of the Milky Way was due to refraction of the Earth's atmosphere. In a treatise in 1755, Immanuel Kant, drawing on earlier work by Thomas Wright, speculated correctly that the Milky Way might be a rotating body of a huge number of stars, held together by gravitational forces akin to the solar system but on a much larger scale. The resulting disk of stars would be seen as a band on the sky from our perspective inside the disk. Wright and Kant also conjectured that some of the nebulae visible in the night sky might be separate galaxies themselves, similar to our own. Kant referred to both the Milky Way and the extragalactic nebulae as island universes, a term still current up to the 1930s. The first attempt to describe the shape of the Milky Way and the position of the Sun within it was carried out by William Herschel in 1785, by carefully counting the number of stars in different regions of the visible sky. He produced a diagram of the shape of the Milky Way with the solar system close to the centre. In 1845, Lord Rosse constructed a new telescope and was able to distinguish between elliptical and spiral-shaped nebulae. He also managed to make out individual point sources in some of those nebulae, lending credence to Kant's earlier conjecture. In 1904, studying the proper motions of stars, Jacobus Kapteyn reported that these were not random, as it was believed in that time. Stars could be divided into two streams, moving in nearly opposite directions. It was later realised that Kapteyn's data had been the first evidence of the rotation of our galaxy, which ultimately led to the finding of galactic rotation by Bertil Lindblad and Jan Oort. In 1917, Herbert Curtis had observed the Nova S Andromedae within the Great Andromeda Nebula. Searching the photographic record, he found 11 more novae. Curtis noticed that these novae were on average 10 magnitudes fainter than those that occurred within the Milky Way. As a result, he was able to come up with a distance estimate of 150,000 parsecs. He became a proponent of the island universe's hypothesis, which held that spiral nebulae were independent galaxies. In 1920, the great debate took place between Arlo Shapley and Herbert Curtis concerning the nature of the Milky Way, spiral nebulae, and the dimensions of the universe. To support his claim that the Great Andromeda Nebula is an external galaxy, Curtis noted that the appearance of dark lanes resembling Wilson Observatory 2.5 meter Hooker telescope. With the light-gathering power of this new telescope, he was able to produce astronomical photographs that resolved the outer parts of some spiral nebulae as collections of individual stars. He was also able to identify some Cepheid variables that he could use as a benchmark to estimate the distance to the nebulae. He found that the Andromeda Nebula is 275,000 parsecs from the Sun, far too distant to be part of the Milky Way. The ESA spacecraft Gaia provides distance estimates by determining the parallax of 1 billion stars, and is mapping the Milky Way with 4 planned releases of maps in 2016, 2018, 2021 and 2024. Data from Gaia has been described as transformational. It has been estimated that Gaia has expanded the number of observation of stars from about 2 million stars as of the 1990s to 2 billion. It has expanded the measurable volume of space by a factor of 100 in radius and a factor of 1,000 in precision. A study in 2020 concluded that Gaia detected a wobbling motion of the galaxy, which might be caused by torques from a misalignment of the disk's rotation axis with respect to the principal axis of a non-spherical halo, or from accreted matter in the halo acquired during late infall or from nearby interacting satellite galaxies and their consequent tides. In April 2024, initial studies involving the magnetic fields of the Milky Way were reported. We now move on to the astrography of the Milky Way, beginning with the Sun's location and neighbourhood. The Sun is near the inner rim of the Orion Arm, within the local fluff of the local bubble, between the Radcliffe wave and split linear structures. Based upon studies of stellar orbits around SGR A star by Gillison et al. In 2016, the Sun lies at an estimated difference of 27.14, give or take 0.46 kilolight years, or 8.32, give or take 0.14 kiloparsecs, from the galactic centre. Bohl et al. Found a smaller value of 25.64, or give or take 0.46 kilolight years, also using a star orbit analysis. The Sun is currently 5 to 30 parsecs above or north of the central plane of the galactic disk. The distance between the local arm and the next arm out, the Perseus arm, is about 2,000 parsecs, or 6,500 light years. The Sun, and thus the solar system, is located in the Milky Way's galactic habitable zone. There are about 208 stars brighter than absolute magnitude 8.5 within a sphere with a radius of 15 parsecs from the Sun, giving a density of 1 star per 69 cubic parsecs. On the other hand, there are 64 known stars within 5 parsecs of the Sun, giving a density of about 1 star per 8.2 cubic parsecs, or per 284 cubic light years. This illustrates the fact that there are far more faint stars than bright stars. In the entire sky, there are about 500 stars brighter than apparent magnitude 4, but 15.5 million stars brighter than apparent magnitude 14. The apex of the Sun's Hercules, at an angle of roughly 60 sky degrees to the direction of the galactic centre. The Sun's orbit about the Milky Way is expected to be roughly elliptical, with the addition of perturbations due to the galactic spiral arms and non-uniform mass distributions. In addition, the Sun passes through the galactic plane approximately 2.7 times per orbit. This is very similar to how a simple harmonic oscillator works with no drag force. These oscillations were until recently thought to coincide with mass life-form extinction periods on Earth. A reanalysis of the effects of the Sun's transit through the spiral structure based on CO data has failed to find a correlation though. It takes the solar system about 240 million years to complete one orbit of the Milky Way, a galactic year, so the Sun is thought to have completed 18 to 20 orbits during its lifetime. The orbital speed of the solar system about the centre of the Milky Way is approximately 220 kilometers a second, or 490,000 miles per hour, or 0.073% of the speed of light. The Sun moves through the heliosphere at 84,000 kilometers per hour. At this speed, it takes around 1,400 years for the solar system to travel a distance of 1 light year, or 8 days to travel 1 astronomical unit. The solar system is headed in the direction of the zodiacal constellation Scorpius, which follows the ecliptic. So moving on to galactic quadrants. A galactic quadrant, or quadrant of the Milky Way, refers to one of 4 circular sectors in the division of the Milky Way. In astronomical practice, the delineation of the galactic quadrants is based upon the galactic coordinate system, which places the Sun as the origin of the mapping system. Quadrants are described using ordinals. For example, first galactic quadrant, second galactic quadrant, or third quadrant of the Milky Way. Viewing from the north galactic pole with 0 degrees as the ray that runs starting from the Sun and through the galactic centre. The quadrants are: first galactic quadrant is 0 to 90 degrees, second is 90 to 180, third 180 to 270, and fourth 270 to 360. With the galactic longitude increasing in the counterclockwise direction as viewed from north of the galactic centre. If viewed from the south of the galactic centre, the value would increase in the clockwise direction, i.e. negative rotation. Moving on to the size and mass of the Milky Way. Starting with size. The Milky Way is one of the 2 largest galaxies in the local group, the other being the Andromeda Galaxy. Although the size for its galactic disk and how much it defines the isophotal diameter is not well understood. It is estimated that the significant bulk of stars in the galaxy lies within the 26 kiloparsecs diameter, and that the number of stars beyond the outermost disk dramatically reduces to a very low number with respect to an extrapolation of the exponential disk with the scale length of the inner disk. There are several methods being used in astronomy in defining the size of a galaxy, and each of them can yield different results with respect to one another. The most commonly employed method is the D25 standard, the isophote, where the photometric brightness of a galaxy in the B band reaches 25 mag/arcsec squared. An estimate from 1997 by Goodwin and others compared the distribution of Cepheid variable stars in 17 other spiral galaxies to the ones in the Milky Way, and modelling the relationship to their surface brightness. This gave an isophotal diameter for the Milky Way at 26.8 kiloparsecs, by assuming that the galactic disk is well represented by an exponential disk, and adopting a central surface brightness of the galaxy of 22.1 b mag/arcsec negative squared, and a disk scale length of 5.0 kiloparsecs. Are you keeping up with this? This is significantly smaller than the Andromeda Galaxy's isophotal diameter, and slightly below the mean isophotal sizes of the galaxies, being at 28.3 kiloparsecs. The paper concludes that the Milky Way and Andromeda Galaxy were not overly large spiral galaxies, nor were among the largest known, if the former not being the largest, as previously widely believed, but rather average, ordinary spiral galaxies. To compare the relative physical scale of the Milky Way, if the solar system out to Neptune were the size of a US quarter, the Milky Way would be approximately at least the greatest north-south line of the contiguous United States. An even older study from 1978 gave a lower diameter for Milky Way, about 23 kiloparsecs, or 75,000 light-years. A 2015 paper discovered that there is a ring-like filament of stars called Triangulum Andromeda Ring, rippling above and below the relatively flat galactic plane, which alongside Monoceros Ring were both suggested to be primarily the result of disk oscillations and wrapping around the Milky Way at a diameter of at least 50 kiloparsecs, which may be part of the Milky Way's outer disk itself, hence making the stellar disk larger by increasing to this size. A more recent 2018 paper later somewhat ruled out this hypothesis, and supported a conclusion that the Monoceros ring, A13, and Triand ring were stellar overdensities rather kicked out from the main stellar disk, with the velocity dispersion of the RR Lyrae stars found to be higher and consistent with halo membership. Another 2018 study revealed that the very probable presence of disk stars at 26 kiloparsecs from the galactic center, or perhaps even farther, significantly beyond approximately 13 to 20 kiloparsecs, in which it was once believed to be the abrupt drop-off of the stellar density of the disk, meaning that few or no stars were expected to be above this limit, save for stars that belong to the old population of the galactic halo. The Milky Way stellar disk is also estimated to be approximately up to 1.35 kiloparsecs thick. So let's move on to the contents of the Milky Way. The Milky Way contains between 100 and 400 billion stars, and at least that many planets. An exact figure would depend on counting the number of very low-mass stars, which are difficult to detect, especially at distances of more than 300 light-years from the Sun. As a comparison, the neighbouring Andromeda Galaxy contains an estimated 1 trillion stars. The Milky Way may contain 10 billion white dwarfs, a billion neutron stars, and 100 million stellar black holes. Filling the space between the stars is a disk of gas and dust called the interstellar medium. This disk has at least a comparable extended radius to the stars, whereas the thickness of the gas layer ranges from hundreds of light years for the colder gas to thousands of light years for the warmer gas. The disk of stars in the Milky Way does not have a sharp edge beyond which there are no stars. Rather, the concentration of stars decreases with distance from the centre of the Milky Way. Beyond a radius of roughly 40,000 light years from the centre, the number of stars per cubic parsec drops much faster with radius. Surrounding the galactic disk is a spherical galactic halo of stars and globular clusters that extends farther outward, but is limited in size by the orbits of two Milky Way satellites, the large and small Magellanic Clouds, whose closest approach to the galactic centre is about 180,000 light years. At this distance or beyond, the orbit of most halo objects would be disrupted by the Magellanic Clouds. Hence, such objects would probably be ejected from the vicinity of the Milky Way. The integrated absolute visual magnitude of the Milky Way is estimated to be around -20.9. Both gravitational microlensing and planetary transit observations indicate that there may be at least as many planets bound to stars as there are stars in the Milky Way, and microlensing measurements indicate that there are more rogue planets not bound to host stars than there are stars. The Milky Way contains an average of at least one planet per star, resulting in between 100 and 400 billion planets, according to a January 2013 study of the five-planet system Kepler-32 by the Kepler Space Observatory. A different January 2013 analysis of Kepler data estimated that at least 17 billion Earth-sized exoplanets reside in the Milky Way. In November 2013, astronomers reported, based on Kepler space mission data, that there could be as many as 40 billion Earth-sized planets orbiting in the habitable zones of Sun-like stars and red dwarfs within the Milky Way. 11 billion of these estimated planets may be orbiting Sun-like stars. The nearest exoplanet may be 4.2 light years away, orbiting the red dwarf Proxima Centauri, according to a 2016 study. Such Earth-sized planets may be more numerous than gas giants, though harder to detect at great distances given their small size. Besides exoplanets, exocomets, comets beyond the solar system, have also been detected and may be more common in the Milky Way. More recently, in November 2020, over 300 million habitable exoplanets are estimated to exist in the Milky Way galaxy. When compared to other more distant galaxies in the universe, the Milky Way galaxy has a below average amount of neutrino luminosity, making our galaxy a neutrino desert. And we're going to finish this video with a history of the formation of the Milky Way. The Milky Way began as one or several small overdensities in the mass distribution of the universe. Shortly after the Big Bang, 13.61 billion years ago, some of these overdensities were the seeds of globular clusters in which the oldest remaining stars in what is now the Milky Way formed. Nearly half the matter in the Milky Way may have come from other distant galaxies. These stars and clusters now comprise the stellar halo of the Milky Way. Within a few billion years of the birth of the first stars, the mass of the Milky Way was large enough so that it was spinning relatively quickly. Due to conservation of angular momentum, this led the gaseous interstellar medium to collapse from a roughly spheroidal shape to a disk. Therefore, later generations of stars formed in this spiral disk, observed to be in the disk. Since the first stars began to form, the Milky Way has grown through both galaxy mergers and accretion of gas directly from the galactic halo. The Milky Way is currently accreting material from several small galaxies, including two of its largest satellite galaxies, the large and small Magellanic Clouds, through the Magellanic Stream. Direct accretion of gas is observed in high-velocity clouds like the Smith Cloud. Cosmological simulations indicate that 11 billion years ago, it merged with a particularly large galaxy that has been labelled the Kraken. Properties of the Milky Way such as stellar mass, angular momentum, and metallacity in its outermost region suggests it has undergone no mergers with large galaxies in the last 10 billion years. This lack of recent mergers is unusual amongst similar spiral galaxies. Its neighbour, the Andromeda Galaxy, appears to have a more typical history, shaped by more recent mergers with relatively large galaxies. According to recent studies, the Milky Way as well as the Andromeda Galaxy lie in what is the galaxy colour magnitude diagram is known as the Green Valley, a region populated by galaxies in transition from the blue cloud to the red sequence, which is galaxies that lack star formation. Star formation activity in Green Valley galaxies is slowing as they run out of star-forming gas in the interstellar medium. In simulated galaxies with similar properties, star formation will typically have been extinguished within about 5 billion years from now, even accounting for the expected short-term increase in the rate of star formation due to the collision of both the Milky Way and the Andromeda Galaxy. Measurements of other galaxies similar to the Milky Way suggest it is among the reddest and brightest spiral galaxies that are still forming new stars, and it is just slightly bluer than the bluest red sequence galaxy. And that, my friend, was a somewhat deep dive into the Milky Way. I really hope you did enjoy it. I know it got a little bit complex sometimes with the terms. A lot of it baffled my mind, to be honest. But I definitely learned a lot of new things, and hopefully you did too, and hopefully you found it relaxing as well. Just reading that gave me some ideas for follow-up episodes, and if you guys give this a like and give this series enough support, I will continue making them. Andromeda Galaxy being one, black holes being another. We could go on for ages, and that's not even going through the different planets in our solar system, so plenty of potential content if the demand is there, so let me know if you would like this series to continue. But for episode 1, that is going to do it for this evening, so I really hope you did enjoy. If you did and you're able to, then please give this video a like and subscribe